Passing by reference versus passing by value. Let's look at passing by value. First, we're going to write a standard function that doesn't use any pointers or references, and therefore it passes by value and not by what we call reference. Now, when you pass by value, a copy is made, and to illustrate this, we're going to keep these variables here. X will be 10, Y will be 459, or let's do this. We'll make it 444, and 7. Two fun numbers, if you're into that sort of thing. All right, so the value of X and the value of Y, and let's display inside main function, okay, before calling next function. Alright, so this will be inside main function before calling next function. Alright. And I'm gonna change this, and we're just gonna display the actual value of X and Y. Okay, and then we're gonna have inside main function after calling a function. Maybe I should say external function. That's what we'll do. We'll say external function after calling an external function, and then that'll be the value of X and the value of Y. Okay, let's create a quick chipmunk-style console menu in which to place our functions. Fast forward.
Alright, and then we're going to just a simple menu here. Just to kind of repeat everything. So I'm going to come up here, and we'll leave our variables there inside of main. But I'm going to do, let's see. Okay, I'm just make a simple while true loop, and we'll set up our sentinel value for sort of a simple console menu. Remember, any simple console menu, you basically have a while true loop or something, do while loop, and then you'd have a sentinel value. And while choice is not equal to 0. Alright, that'll be what we choose to use to quit. Or if it makes, I don't know, is that more, maybe that's more convoluted or confusing. Maybe we should instead use a string or a character array. We could do that. Sure. And we'll just make it empty, start out as empty. And we only need to switch on the first character here. And there. That way maybe, I don't know, maybe it's easier. I'm trying to, I can't even talk right. I'm trying to make this easy to assimilate, or hopefully explain this in a good way. So work with me or help me out here. But inside of our menu, we're just going to display these items here. And I just want to do this because we're going to write several functions. And this way we can just, we don't have to, we can just have this loop repeat here as a menu. And we'll get to see the results of each function that we write. And the first one we do will just be passing by value. But let's throw that in there. Okay. And then we will simply display some options here. Choose an option. And a couple of lines. Alright, so one is passed by value. And that'll be sort of our menu item there. Alright. Alright. And Q will be quit. And let's do this, and we'll just make a little box for our menu. Alright. And Q will quit, right? And let's go ahead and point the data frame operator at our variable, and we'll take input via choice. And let's switch on the first character of choice. Alright. And this will be sort of our template. Okay. Invalid response. Alright. This will be sort of our basic menu here. And let's see, let me build that. I'll just make sure right now it doesn't do anything, but okay, it looks halfway decent. Maybe we'll drop the cursor down a little bit. Alright, so value of x, value of y, and then we'll throw our functions in here. Alright, so we just made a basic menu.
Let's prototype and define our function that passes by value. If I define my functions down here under main, I have to prototype. If I define it above, I don't need to prototype it. I'll do them down here just so we can kind of do it the prototype way or whatever. So I'm going to make first function void, and we'll call this one pass by value. Okay, and pass by value, we'll throw some code in there to swap values. It's going to accept 2 arguments, and we'll just pass these in as we'll go in as A and B. Okay, or we could, doesn't matter, it's local to the function. I don't know, some people think this is more confusing. We could use X and Y, but although because of scope these are completely different from this X and Y, if that's confusing, or maybe we could just use capital X and capital Y. And that way, even though by scope they're different, now you can look at them and you know, hey, that's cap X, that's cap Y, that's lowercase x, lowercase y. You know, however you want to look at that. Alright, so we're going to take 2 arguments in this function, and we need to prototype it. So that means up here, and it's void, and the function signature passed by value, semicolon, and alright, I just need to add the signature up there, and I think that was a capital V there. Should have just copied and pasted. Yeah, there we go. Alright, so if that's the case, then to call the function, alright, to invoke it, we're going to pass in this X and this Y, right? These are local to main. Alright, so I'm going to get rid of the white space there. So I'm just going to pass in lowercase x, lowercase y. It doesn't matter by scope, they're different anyway. Remember that when you're in a function, all the variables in that function are temporary to the function because of scope, unless something's global. Now, if I declared a variable out here in my global namespace, then it will persist in memory and it's global. But anything I declare here inside of main, like x and y, it's local to main. Once I leave main, those variables lose relevance. Likewise, if I were to pass x and y in to this function, and I'm not passing by reference, in other words, I'm not using pointers, I'm not using references or aliases, then the actual variables themselves are not passed in. Rather, copies are made, and the copies get passed in. And we'll illustrate that point by showing the value of x and y, and then calling this function and seeing the end result. So I pass it in, but deceptively, perhaps, in Java, that would, you'd look at that and you would think, well, that's by reference, but in C++, that's by value. Okay, so it's just a temporary copy being passed in. Whatever I do, kind of like they say, what happens in Vegas stays in Vegas. What happens inside this function here stays in this function. And when it's done and the function ends, all those variables, including the local parameters here that we pass in, they're all destroyed. And you'll see that it'll have no effect on the actual x and y inside the main function. Alright, so we prototyped it, we call it, we define it, and we just want to use our same code there, right? We're going to swap it, so I'm going to make a temporary variable here, and I'm going to assign it the value of x. And then I'm going to go ahead and take x and give it what's in y, and then I'm going to take y and give it what's in tone. So that'll swap the values, okay? And maybe just a little feedback. Maybe we'll do this as well. Come over here inside the function, and I'll throw some code in here. Inside external function. And then we got capital X and capital Y here. Before swap. Okay. Alright, and throw that down there. So that'll show the parameters, right, that were passed in before the swap. And insertion function, this will be after the swap, and then we'll show. Okay. Before we run this, I'm just going to add a pause and a clear screen at the bottom here. And again, the utility of that will just be to kind of clear things up and give us a clean slate to start with. All right. So let me rebuild this, and we will run it in Bloodshed. And let me stretch this down a little bit. Change the background colors a little bit. Okay, so here we are, and we're inside of main, and let me slide this over here if I can, if I may. And go up here. And so X and Y start out as 7 and 444, respectively. And that's what's displayed here. Now let's go call our function pass by value. So when we do this, before we call the external function 7 and 444, we go inside the external function, we pass them in, X and Y, in the same order. They're still 7 and 444. Okay, so they come in as X and Y, 7 and 444. Before the swap, 7 and 444. And then we do the swap right here, right? And then, as it should be, 444 and 7. But when we get back down to main, notice that it's 7 and 444. The same as it was before. Nothing actually changed in the function because a copy was passed in, and not a reference or a pointer to the actual variable or object. All right. Let me exit here. Just some quick code for aesthetics. All done. But again, if I do this, I'm going to pass by value. 7444, 7444, swap. And then when we get back to main, nothing actually changed because it was a copy. Now let's take a look at passing by reference. In example 1, we'll use pointers. So let's code our next function, and this time we want to pass by reference, which means instead of actual integers, we want to use pointers. So I'm going to copy and paste the first prototype. We'll modify the name, and we'll call it pass by ref, because that's what we're doing. And there's more than one way to pass by reference. You can use pointers, or you can use references or aliases. So we'll just call this one underscore pointers. All right, pass by ref underscore pointers. Now, instead of integers, we need pointers, so I'm going to use the asterisk to make X and Y pointers to integers and not actual integers. So there's our prototype. For the function definition down here, I'm going to copy the code for our first function where we pass by value, and we'll just modify it to use pointers instead of integers. And let's modify the name to match our prototype. Okay. All right, so now we haven't converted it yet, so notice it's the exact same code as our first function. So how do we code this function to accept arguments, take parameters by reference and not by value? Well, the trick is to use pointers. So I'll put my asterisk in front of X and Y, and now X and Y, like my prototype, are pointers to integers and not actual integers. When I do this, of course, that's going to fundamentally change the way X and Y are utilized throughout the function. Whereas before, I could just display X and Y and assign values, but they were only temporary. If I did this now, I would get memory addresses. I wouldn't get the actual values. Well, I don't want memory addresses. I want the value stored in the pointee that the pointer points to. So that means I have to use the asterisk again to dereference X and Y to display its value, to store its value in the temporary variable, to assign what's in Y and store it in X, and then take what's in temp and store it in Y. To get to the pointees, I have to do all this dereferencing with the asterisks all the way down. And the same thing down here. I don't want a memory address, but I want to dereference X and Y and reveal the values of the pointees that they point to. So I do all that, and that's passed by ref pointers. So there's our definition, and here's our prototype. Now let's just go in and add a quick menu entry to go along with it. So I'm going to come in here, I'm going to add a menu entry number 2, and this will be passed by reference, and we'll say pointers. That'll display the menu choice. Now I have to build a case for it in the switch statement. So if case 1 is passed by value, and case 2 will do our pass by ref function. And it was it passed by ref, lose all caps pointers. Okay. Let's check our prototype. Pass by ref pointers, yeah, pass by ref underscore pointers. Okay. So now when it doesn't just change the way we define and prototype the function using pointers instead of integers, but it also changes the way we call or invoke the function. Because look, since this takes arguments by value, I just pass in actual x, actual y. I'm expecting 2 integers. You can see in the pop-up in Dev C++ or Bloodshed. On the other hand, if I take a look at this function, it's not expecting actual integers. It's expecting pointers to integers. Okay, so I can't really pass in an x and a y like that. If I compiled this, it'd be a syntax error. As a matter of fact, to illustrate the point, let's compile it and we'll take a look at the syntax error generated. Okay, invalid conversion from an integer to a pointer to an integer. So I can't do that. I'm passing by reference. Instead, I have to use my ampersand or the address of operator and pass in the memory address of x and the memory address of y of the pointees. All right, so I'm going to do that. Ampersand x, ampersand y, address of operator. And then if I rebuild it, okay, now my syntax is okay. In addition to my syntax, this will fundamentally change the logic and the scope. Because now, whatever I do inside that function, if I were to call function 2, the second choice on the menu, instead of 1, then these original values will be modified. Unlike in the first example, where the original values were not modified. They remained unchanged. So to illustrate the point, let's run it. And I'm going to run it, pull the console up over here, and we'll do pass by ref. So if I do pass by ref, notice that we start out, and the value of x and y, I'll scroll down here a little bit, 7 and 444. So if you look in the console, 7 and 444, right? We're going to choose option 2. So when we do, what's going to happen? It's going to go call pass by ref pointers, pass in the address of x, the address of y, which goes in no longer by value but by reference, and swap it. And you'll notice now everything done to the x and the y actually affects the original x and y inside of main. So let's enter the 2. And whereas it started out x was 7, y was 444, we go into the external function that we called, all right, pass by ref underscore pointers. X comes in as 7, y 44. We swap it. X is 444, y 7. We leave, we come back out in main, and now you'll notice that the original values were swapped as well because it was done by reference via pointer. So up here, x is 7, y is 444 inside of main before we call the function. Well, after we're done, back in main, x is now 444 and y is 7. So that kind of illustrates the fundamental difference between passing by value versus passing by reference. Again, we're going to look at passing by reference, but this time in example 2, we'll use references or aliases. Now, if that's not enough to entertain you, to make our lives even more interesting, there is another way to pass by reference in C++, and that is using references, okay, or aliases for variables. So in addition to pointers, I'm going to write another prototype, and I'm going to pass by reference again, but this time instead of pointers, I'm going to pass by reference using references. And to do this, I'm just going to copy this prototype here, and we'll call it pass by ref, but this time we'll call it references. All right, references. All right, let me do that all caps. Okay, since pointers is all caps. I'll try to keep it consistent. Instead of the asterisk, I use the ampersand. Now, in the same way that the asterisk can be used in multiple ways, right? The asterisk could be multiplication. The asterisk could mean that I'm setting up a pointer. Or the asterisk could mean I'm dereferencing a pointer. So it's context sensitive. You know, the asterisk is used in different contexts, and depending on how you use it, that's what the asterisk is. Okay, that's what we mean. But so in the same way, the ampersand is context sensitive. So it could be the address of operator, depending on how you use it when you're passing in variables via pointer. but it can also mean that you're setting up something to be a reference or an alias to a particular data type, in this case to an integer. So in this context, it's not really operating as the address of operator, so to speak, but it's saying figuratively that we're setting up x and y to be an alias or reference to an integer. Okay, so we code the prototype like this, like so. And now I'm going to go and I'm going to copy this function again, the pass by value function, okay? Trying to save time here. Just like we copied it for the the function we made with pointers. And I'm going to copy the prototype name. So we have pass by value, pass by ref pointers, and pass by ref references. Pass by value, pass by ref pointers. Come down here to this. Okay. Now I want you to see something. Here I had to fundamentally change everything as far as the way I accessed x and y because of the pointers. This code, if you look at it, other than I need to make these references, so I'll put my ampersands in there. So this declares x and y as aliases or references to an integer. But other than that, if you look at the code, I don't have to dereference. I don't have to use the ampersand or an asterisk or anything like that. This code, if I were to copy and paste the code from the pass by value function right here and just copy it, matter of fact I will, just to prove a point. I'll come down here and in my function where I'm passing my reference, I'm going to paste that code. And I guess I should, I don't really have to, I could change that and make it say the function name, but we get it. If we choose option 3, we know, so I won't worry about that. I'll try to shorten the amount of time I'm wasting, or the amount of your time that I'm wasting in this tutorial here. Sorry, I'm getting chatty. Anyway, so that illustrates the point, right? That this is the exact same code as passing by value. But here's the cool thing about an alias or a reference. You get the features that you normally get via a pointer, passing by reference and more efficient use of memory. But the cool thing is it simplifies the code. It sort of hides the complexity because you don't have all the dereferencing going on here and the pointer assignment with the address of operator. So it simplifies the function definition. I also want you to see something else. It also simplifies the way you invoke or the way that you call the function. So to do that, we need to add a third menu entry. So let's do that. I'm going to come here. I'm going to add menu option 3. And this is passed by ref with references. References. Okay, we need to make some space here now. Kind of slide those over some. Alright. So this passed by ref references. I need to build a case for it in my switch statement. I want the break there, so this will be case 3. This is passed by ref with references. And if this were like pointers, I'd have to use the address of operator. But this would actually be a syntax error. Alright, if I were to compile that, it'd be a problem. Here's the cool thing about a reference or an alias. In the same way that I just passed in x and y, and in the same way I invoked or I called the function pass by value, I can call the function pass by ref with references, no ampersand required, and no asterisks required down here. But when we run it, you'll notice that it has the exact same effect as the second function that we wrote, passing by ref using pointers. Two different ways to pass by reference, but they achieve the same results. It's just that using an alias or a reference hides the complexity of pointer usage. And because of that, a lot of programmers prefer using references over pointers. But you can use them interchangeably for the most part. Although pointers can be easily reassigned, and a lot of times a reference or an alias is utilized as a permanent alias for something. And the idea is not to change that alias or not to reassign that reference. But other than that, they pretty much do have the same effect. But some programmers prefer references more than pointers because it hides the complexity. And I guess for the same reason, some programmers hate references. They like pointers because it illustrates the mechanics of memory management and memory addresses, how they're being assigned from the pointee and the pointer to another, to different objects and things on the heap or the free store. So I guess if you ask 10 different programmers, you get 10 different opinions on that. But all we're trying to do is point out that there are different ways to pass by reference, but ultimately you can achieve the same results if you use pointers or if you use references. So let's build our project, check our syntax, and let's run our project. All right, so once again, looking at the code, x starts out as 7, y starts out at 444. This time let's call function 3, and we'll pass by using references. When we do this, x comes in as 7, y 444. Inside the external function, we swap it. X is now 444, y 7. Back in main, behold, x is 444 and y is 7. Whereas before, when we started up here, x was 7 and y was 444. So even though it's not a pointer, we accomplish the exact same thing as we did, in running function 2 by pointers, but sans all the dereferencing and the asterisks and having to use the addressive operator or the ampersand when we passed variables into the function. So two different ways to code functions that accept arguments or have parameters by reference instead of by value. So if passing by reference is more efficient, why would anyone still want to pass by value? And you might be asking yourself, well, why would anybody want to code a function to pass by value? Most of the time you don't. Most of the time it's more efficient to code functions via pointers or references, aka aliases, because that way you're not generating a copy and wasting system resources. You're actually just passing in a pointer to the original address. But there are some times where you do want to pass by value. You might have situations where you don't want the original values in a function that's calling another function to be modified for security reasons or for backup purposes. And so there are some situations where passing by value is really what you want to do. But probably most of the time, passing by reference is what you want to do. It's just more efficient.